One more problem for you. It's a conceptual problem. See the diagram carefully. A girl at the pole bought 1 kg of gold as per her friend's instructions. But her friends not at the poles, they're at the equator of the earth. So what she did, she bought the gold, 1 kg gold at the pole. She has traveled to the equator to meet her friends and she has shown the gold. Now the question is, do the friends agree with the weight of the gold what she was expressed to them? No. Why? G, which is acceleration due to gravity at poles, is greater than equator. And weight, the formula is mass into gravity. Okay, mass is constant everywhere, but weight is directly proportional to G. When G decreases, weight decreases. When G increases, weight increases. So at poles, the G is more, therefore weight is more. At the equator, the G is less, so weight is less. So even though she at poles, she bought the gold and she weighed that 1 kg, but when she comes to the equator and once again she measured the gold, it need not to be 1 kg gold. It is less than 1 kg. So therefore, weight of gold equals to, not equals to, is less than 1 kg at equator. Because at equator G is less. See how strange it is. That's what I told in the previous concepts. The G value what you have found, 9.81 meters per second square, is not the exact value, it's the average value. Different places of the earth, you have different G's. So scientists have calculated all the G's and taken the average, and that average value they have given to us as G equal 9.81 meters per second square. So as usual, weight of the gold at equator is less than 1 kg than at poles. One more conceptual problem for you. This is a sheet of paper falls slower than the one that is crumpled into a ball. So you have taken a sheet of paper like this. It's a sheet of paper. In the first case, the sheet of paper is just like a plane. It's falling to the ground. You have taken the same sheet of paper and crumpled into a ball like this, and it is also falling. Now in these two cases, if you observe, the question says the sheet of paper falls slower than the crumpled ball. Why? Yeah, the answer is with you. When you take a sheet of paper, the sheet of paper occupies more amount of area. As it occupies more amount of area, it has more air resistance acting in upward direction because it is falling into the air. So there is more amount of air resistance acted at different places of the sheet. So the more air resistance balances the weight of the sheet of paper. Or sometimes the air resistance is more than the weight of the sheet of paper. Due to this result, the sheet of paper falls very slow to the ground. When it's crumpled, it occupying very less amount of area. So therefore, you have very less amount of air friction. That's why the crumpled ball falls faster than the sheet of paper. One more numerical problem. There is a ball on the top of a tower of height 19.6 meters, and the ball has dropped and it reaches the ground with the maximum velocity v. Now the question is, calculate that maximum velocity or final velocity at the ground. So how do we solve? Just apply the concepts what we have learned. A ball is on the top of a tower of height 19.6 meters. The ball has just dropped and reached the ground with the maximum velocity v. Now the question is, calculate the final velocity at the ground. The final velocity and the maximum velocity both are same. So this is also a numerical problem for you. Now how do we solve? Before solving it, apply the concepts what you learned. As the ball dropped freely at initial point, the initial velocity u is 0 because it's a freely falling body. Height 19.6 meters, and as it is falling to the ground towards the earth gravity, the acceleration A is g. So you know u, v, a and height, you need to calculate v. So which formula you can use? Think about equations of motion. The formula you can use is v square minus u square equals to 2as. So v square minus u square is 0 equal to 2 into g. You can take 10 meters per second square, but 19.6 is the multiple of 9.8, so we are considering 9.8 and height is 19.6. So v equal to square root of 2 into 9.8, which is 19.6 into 19.6. Now the answer is very clear for you. It's very simple now because it's the square root of two similar numbers. So the answer is 19.6 meters per second. One more problem for you. There is a ball has thrown upwards with velocity 40 meters per second and reaches to maximum height. I need to calculate what is the maximum height reached. So after reaching the maximum height, the ball doesn't stay at that point for a long time. It again comes back to the ground. So the second question says, what is the net displacement and distance after it falls to the ground? Well, let us solve with the first one. A. Maximum height reached. Just recall the formula. The maximum height h equals to u square by 2g. Okay. Now u is initial velocity 40. So 40 into 40 by 2 into g. Here you take 10 to simplify the numerical easily. So 0, 0 cancel 2 times. So this is 80 meters. The height reached is 80 meters. Now second part. What is the net displacement? You know the displacement is a vector quantity. If the ball goes in upward direction to reach the maximum height here, so this is A, this is B, upward, so the displacement is S. And the ball comes back to the ground, then it moves from B to A, downwards, and the displacement is minus S. So net displacement, we need to add the two displacement S minus S, and it is nothing but 0. Displacement is 0. Now distance, the total distance traveled. Distance is a scalar quantity, so you can take the path. So from A to B, the distance covered is h, which is 80 meters. 80 meters plus B to A, one more 80 meters. So 80 plus 80, this is 160 meters. So distance traveled is 160 meters. So one more numerical problem for you. Of course, it's based on the formula force of gravity, or Newton's law of gravitation formula. The problem is Earth is revolving around the Sun. This is the mass of the Earth, mass of the Sun, this is the mass of the Earth, R is the distance between the Earth and Sun. Now you need to calculate the force of gravity between Earth and Sun. So quickly write the force formula, F equal to G m1 m2 by r square. Now force F equals to the G value 6.67 into 10 power minus 11, and mass of the Sun 2 into 10 power 30, and mass of the Earth 6 into 10 power 24 by r square. R square is 1.5 into 10 power 11 whole square. If you keep on simplifying all these numbers, see how I am doing. 6.67 into 62612 into 10 power 30 plus 24 54 minus 11 by 1.5 into 1.5 into 10 power 22. Now upon simplifying this fraction, the last answer you get 135.57 into 10 power 21 Newton. So this is the force of gravity between the Sun and Earth. In other words, this is the force value with which Sun pulling the Earth. Similarly, Earth is pulling the Sun.
If you like this video, please give a thumbs up. Please subscribe to our channel to get more videos on CBSE syllabus.